All right, today we will be talking about, as you see on your screen, how to classify real numbers. So as usual, I'm going to introduce this by first starting off with our questions we want to answer. And pull up my pen there. And we only got two questions really I want to answer, and that's how to identify rational numbers and irrational numbers, and how to classify different types of real numbers. So we're going to cover that here pretty quickly. First of all, what is a rational number? So the rational number, if you notice, has the word ratio in it. Let me get my marker out. So you can see the word ratio in it. So you can still think about it as a ratio. A rational number is a number that can be written in the form P over Q, or as a ratio between two values. So where P and Q are some integers and Q is not equal to 0. So are fractions rational numbers? Well, that should be pretty clear, because since a rational number can be written in that form, you should realize that this is a rational number because it's written P over Q. It can be written like that. Then it's a rational number. What about integers? Well, integers are numbers like 1, 2, 3, 4, negative 1, 2, 3, 4, 0, all those numbers. Are those rational numbers? Well, since those numbers can be written as fractions, we can just put a 1 on the bottom and make that a fraction. Then it still is considered a rational number. What about decimals? Can decimals be considered rational numbers? Well, decimals, let's think about 7.3. Can that be written as a fractions? So can we write it as a ratio of two different integers? And if you look here, 7 and 3/10 can be written as an improper fraction of 73. That's a integer. Over 10, that's an integer. Since it can be written as a fraction with two integers, then yes, 7.3 is also considered a rational number. All right, so let's practice this. Write each one of these as the ratio of two integers. So remember, in integers are the numbers 1, 2, 3, 4, 5, 6, 7 all the way up, and all the negative numbers as well, including 0 in the middle. So let's write this as negative 15 over 1. So that's a rational number. This can be written as a rational number because this is the same thing as 6 and 81 over 100. But this is not a ratio yet, because I need a integer on top and bottom. But I have a whole number here. So to get that, we're going to do 6 times 100 is 600 plus 81 gives us 681 over 100. Now this is set up as a ratio, so now I know it's a rational number. And same thing here. 3 times 7 is 21 plus 6 is 27 over 7, and that's negative. So there's two integers here, just like here and here, and so all these are rational numbers. So here's a summary of what we just talked about. If you're dealing with numbers and looking as a fraction, all these can be considered rational numbers. Here they are as integers. A ratio of integers looks like this, same as up top. We took these integers and put ones on the bottom, which made them a ratio. And decimals, we said we can just write the same thing and just put the tenths place, hundreds place, whatever number they're in. Watch this. This line, if you remember, is what? That means it's a repeating decimal. So this can be written as 2/3. So that is a fraction. So this would be negative 6 and 2/3. So you could rewrite that one as 18, 19, 20, 20 over 3. So even though it does repeat, it can still be written as a fraction because it is repeating, and it's a consistent repeating that can be written as a fraction. So keep that in mind. And all these are fractions too, because we can just write these in the with the tenths place, hundreds place, and so on. So let's move on. What about an irrational number? Well, an irrational number, as you can imagine, is a number that cannot be written as a ratio of two integers. So it cannot be written. Its decimal form does not stop, and it does not repeat. So let's identify each of the following as either rational or irrational. Well, let's look at this one. Is this rational or irrational? Well, that's kind of tricky, isn't it? because we have a repeating 3, but the 58 is just by itself. But since this is repeating, this will be considered rational. This can be written as a fraction of 2 integers. What about this one? Well, without even doing the math, we can know that this is 475 over 1,000 because that's in the thousands place. So we can say the same thing here. These are 2 integers. This is a rational number. What about this one? So this dot 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 means this number keeps on going on. But there's no problem with that if it repeats. But do you see anything repeating? No. So you see 5, 5, 5 there. There's no pattern that keeps going. So this is going to be considered irrational. Rational. All right, so let's identify if these are rational or irrational. Square root of 36. Well, square root of 36 is 6. And I know that 6 is just an integer, so that is rational. What about square root of 44? Well, square root of 44 is an imperfect square because I know it's between 6 squared, which is 36, and 7 squared, which is 49. So it's somewhere in the middle between here. So it's going to be 6 point some number. And I'm pretty sure that number is not going to repeat, but you could always check it. So if I want to pull my calculator up here and double check, I could do that. So let's do the square root of 44. 44 square root. And look at that. Number does not repeat. There's no pattern. And so that's going to be irrational. All right, so here's how one way you can see it. Oftentimes when you're talking about real numbers, is you see some kind of Venn diagram that shows you how they're organized. What this is trying to tell you is that everything inside this box is a real number. That's why it's out here in the green, this huge part. All these are real numbers. But you break it down further, you have some of those real numbers are rational and some of them are irrational. And within those rational numbers, some of those rational numbers are integers. Some of those integers are whole numbers, and some of those whole numbers are counting numbers. So all counting numbers are whole numbers, all whole numbers are integers, and so on. We can keep on going out. So let's kind of practice here. I'm going to put up some numbers, and I want you to tell me where does this number go. So let's look at -7. Let me get a pen. Let's see. That'd be a good color. So -7. Where would I put my -7? So is it a counting number? Well, do you normally count using -7? No, we don't. And -7 when we count. So this is going to be, is it a whole? So counting numbers are your 1, 2, 3, and so forth. The whole numbers are going to include 0, 1, 2, 3. Your integers are going to include negatives, -1, -2. So this is where we're going to put our -7. So our -7 goes with integers. Let's put -7 here. So check, we got that one. What about this one here? 14 over 5. Where would that one go? Well, it's definitely not a counting number. It's not going to give me a whole number. So it's not a counting number. It's not a whole number like 0, 1, 2, 3, 4. It's not a integer. It looks like it's going to be a decimal. Like if I divided these two, 14 divided by 5, I get 2.8. So it's actually 2.8. So where would that one go? 2.8. It's not going to be an integer. It's rational, yes, because I can make a fraction out of it, as you can see here. So we could have just said real numbers. All these are real numbers, but we want to get as specific as we can, and the most specific we can there is rational number. What about 8? Well, 8 is easy because that's just a counting number. So got that one. And square root of 5. All right, so square root of 5 is going to be, let's do 5 square root of 5, and nothing's repeating there, so this thing goes on and on. That's definitely going to go with irrational. Square root of 5 is irrational. 5.9, that's going to be with our rational. I shouldn't erase the rest of those. And negative square root of 64 is this is going to be 8, so that's going to be negative 8, so that goes with our integers. So that's what you want to see there. Now here's a little bonus that I will include, because it's kind of weird when they talk about real numbers as if there's such thing as non-real number or imaginary numbers. Why would they call them real numbers and not just simply numbers? Well, because funny enough, there is a such thing as imaginary, I think that's how you spell it, imaginary numbers. So, and you'll get into that later on in Algebra 2 maybe, or intermediate algebra, whatever it's called where you are. So, but we won't discuss that here. But there is a such thing as imaginary numbers that are discussed at another time. So here's a summary of what we covered. Negative 7 was the integer and the rational. 8 is whole integer, because we said it includes everything within that box. So it's a whole number, integer, and a rational. Square root of 5 was irrational, and 5.9 rational. Negative square root of 64 is integer and rational. So did we cover what we wanted to? Yes. How to identify rational numbers and irrational numbers, and how to classify different types of real numbers. So great job at that. And that is it. Thanks for tuning in, guys. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.